I'm Anil Kumar, and here is another question on absolute maximum or minimum. We'll try to now find absolute minimum or maximum using the algorithm. Question here is, determine the absolute extrema of each function. Illustrate your answer by sketching the graph, right? So there are two questions. You can pause the video, answer them, and then look into my suggestion. The first one is a parabola. F of x equals to x plus 2 whole square, and we are given a domain which is between minus 3 to 0. The second one is a straight line, g of x equals to 2x minus 1, between minus 1 to plus 1. Now, the criteria for finding absolute maximum minimum is that f of x should be continuous. So both are continuous functions. So both are continuous, right? So continuous in the given domain. Both are continuous. So the criteria is not that they should be differentiable. Indeed, these two are differentiable, but there could be some functions which are not differentiable but are continuous. And you can apply the algorithm to find the domain. So this is first part. Now, second part of this question is, the steps to do is figure out what are the critical points. To find the critical points, we find the derivative of the function. So derivative of this function is 2 times x plus 2 times 1. So that is the derivative. And equate this derivative to 0 or does not exist, right? So this derivative is 0 at x equals to minus 2. So critical number for us is, let me write here, critical number is x equals to minus 2, right? So that is the second step. First, check whether it is continuous or not. Second, find the critical number. Third step is find all the values. The values which we are interested in are the boundary conditions. That means f of minus 3, find this first. F of minus 3, substitute minus 3 here, whole square, and that is equals to minus 1 square, which is 1. And then the other extreme value, which is f of 0, substitute 0 in the equation given to you. 2 square is 4. And also find the value at the critical number, which in this case is minus 2. At times you could have more than one critical number. So at minus 2, if I write minus 2 here, minus 2 plus 2 whole square, I get 0, right? So these are my different values. And from these values, you can compare absolute maximum minimum value. So we know minimum value amongst these is indeed 0. So that is absolute minimum. Is it okay? And here, f at 0, we have maximum value of 4, which is absolute maximum. Is it okay? So that is how you should be answering the question. And therefore, you can say that absolute, so you can write down answer, that absolute maximum. So determine the absolute extrema of each function is at what? Maximum is at 0 and the value is 4, right? And absolute minimum is at minus 2 and the value is 0. I hope that is absolutely clear. And then we need to sketch this graph. So let me just sketch it on the side. So I'll make a small sketch here, right? So we have very limited space. Minus 3 to 0. So minus 3, let us say this is minus 3. We found that at minus 3 the value is 1 for, is at minus 3 the value is 1 for us, right? And then we had 4. So let us say this is 1 for us at minus 3. At 0, the value for the function is 4. So this is at 0, the value is 4, let us say. And at minus 2, the value is 0. So set minus 2, the value is 0. So the function, which is a parabola, is kind of like this, right? So that is the function, right? So this is minus 3, minus 2, and 0, right? So that's a small sketch. You can do a better job than this, of course. Okay. But I hope it serves the purpose and you at least understand what we have done. Okay. Let's follow the same steps and do the second question now. G of x is a linear function. So let's find derivative of g of x. It is 2. So it is never 0. So no critical point. So no critical number, right? So that is first thing. So in that case, what we do, we go to find the value of the function at two boundary conditions, which are -1 and 1. So if I write -1 here, I get 2 times -1 minus 1, which is -3. And at 1, it is 2 times 1 minus 1, which is 1, right? So these are the two values. And compare these values. That is the next step. So the algorithm says, first check whether the function is continuous or not. Second step is find the critical numbers. Third step is find the value at critical numbers and at the boundaries. So now compare them. So we get absolute maximum is at 1 and the value is 1, and absolute minimum is at -1 and the value is -3, right? So you can sketch this function. So let me use this space here to sketch the function. At 1 it is 1, -1 minus 3. So I'll kind of sketch it here. So at -1 it is -3, and at 1 it is 1. If I write 0 here, I get -1. So it kind of goes like this. Okay, that is fine. So we'll now label it. So this is at 1, we have a value which is 1, right? And at -1, we have a value which is -3. So that is how we get our linear function within the boundary which is given to us. Now, you should remember one more thing. For finding absolute function, we could have, it is bound from both sides. So it is bound from both sides, right? In these examples, we do have examples where the boundary could be bound from one side, okay? So look into those examples also to understand the concept completely. Thank you and all the best.